And there we have it. We've learned stacks and queues. And an easy way to remember them is just simply plates and a waiting line. We learned why they're built on top of other data structures like linked lists and arrays. And we also talked about how to build stacks with arrays and linked lists, and also why we might not want to use an array to build queues, and also build a queue data structure with linked lists. We learned that stacks and queues are great for some fast operations that they have, such as removing or inserting, such as at the end of the data structure. We can also access the very first item in a queue or the very top item in a stack. And we also have all our data ordered, which is really, really nice. But we don't usually use our stacks or queues to really do any sort of lookup or search through the data structure. All we're interested in is the end bits of the data structure. So they make it really useful by restricting our use of what we can do when it comes to stacks and queues, but making sure that what we're allowed to do with these data structures are going to be really, really fast. And there we have it. We've continued to expand our mind map of data structures. So we completed our stacks. We learned how to create stacks with arrays and linked lists. We've learned about their big O notation. And we also talked about queues and how we wouldn't really want to use an array for a queue, a very common interview question. We learned how to use a linked list to create a queue. And also we learned about the big O implications, which is very similar to stacks. We're getting closer and closer to filling out this mind map. But before we do that, we still have a few more data structures to go. But the end is almost near. We only have trees and graphs to talk about. For that, I'll see you in the next part. Bye-bye.